And the idea was to essentially create an undergraduate research community at McMaster, and we invested in it. So we invested in it by investing in first-year students through the Dean's Excellence Awards, and we bundled it together with the NSERC USRA program. So fast forward, I think 5, 6 years later, time passes very quickly. We now have the largest undergraduate research experience at any school in Canada, and one of the largest worldwide by the proportion of students who go through it. Every year, not just in the summer, about 300 odd undergraduates go through professors' labs. And I'm so glad that John Preston asked me to do that counting a few years ago. I did a survey of engineering deans elsewhere. So it's exciting. You're part of a special community. We have a very strong commitment to undergraduate research. The whole objective of this was not really to make everybody into a researcher who would go into graduate school. Some of you will, and some of you may not. But the whole idea was to be enthralled with discovery. And there's a certain satisfaction to being a discoverer. You know, we have geographical discoverers, although that geographical discovery now is less and less because we know our planet. But there are so many things that we don't know about the natural world and the physical world. And what you're going to be embarking on is a journey to investigate that natural world, that physical world. And that's not an opportunity that many people have. So you're privileged to have this opportunity. You're fortunate to have this opportunity. And I say this because I want you to make the most of this opportunity. Make the most of this opportunity and understand what discovery is, understand what inquiry is. Many of you will not just be inquiring, you'll be working on projects that are translational, which means that you will be taking lab knowledge and helping solve important societal problems. Societal problems related, let's say, to climate change. How can we use less fuel in conventional steel making, for instance? Problems related to biomedical discovery. How can we make better use of microchips and of microfluidics to really look at drug discovery, for instance? These are cutting edge, exciting problems that you'll be participating in. Now, the problems are huge. You'll also learn that what engineers do is they take a huge problem and split it into tiny parts. So many of the responsibilities that you will have will be a tiny part of that huge problem, and you'll be contributing to that solution. But while you're working on that tiny part of the solution, you'll be able to see how your group, your mentors are able to stitch together different solutions into a large system-wide solution. And that's the magic of discovery. That's the magic of translational science. When I came, I had several conversations, and we decided that the tagline of the faculty should be that we educate, engage citizen scholars who transform the world. There's no word of engineer there, or computer scientist, or engineering technologist. Engaged citizen scholars who will transform the world. And that's what we want you to become. That's what you are. Be engaged with the world. Be engaged with the world through your discovery. We are educating you to do that. Become scholars. Scholars think on a higher level. They reflect on their discoveries. What did I find? What does it mean? Reflect upon your discoveries. And essentially, become citizens. Be invested in our society, the betterment of our society, so that over your lifetimes, you are the ones who will transform the world. Our world faces so many grand challenges. Look around you, COVID is one of them. And in order to really solve these grand challenges, we need the combined efforts of all of you solving tiny bits of that jigsaw puzzle. And when you do that, we'll clear the jigsaw, we'll see the solution very clearly, and life will be better. So I'm really pleased to be here. The expansion of the undergraduate program was an initiative I was part of, and the people who put it into motion are here today. And in some ways, this may be the last time we are together because some of us are going on to do more exciting things in our future. But there's a story there that in order to change the world, you have to collaborate. And when you collaborate, you find a solution. You'll move on to another problem, to developing another solution, but you will leave a legacy. And this is the legacy that we want you to carry forward, is do things that are meaningful, that will transform the world. So thank you very much for having me here. I think that it is my privilege to introduce John Preston, one of the originators of the program, and having talked him up so much, I'm sure he'll have something very profound to say.
Thank you, Dean Puri. Dean Puri also read ahead in the notes and took some of my best lines out of my speaking notes. So that's okay. That's prerogative of being Dean. So I'd like to welcome all the student researchers here. This is going to be the 2021 McMaster Engineering Summer Research Cohort. You're going to do some absolutely amazing things this summer, as was stated. And we look forward to hearing about it, collaborating with you, and helping you to make the most of it. McMaster Engineering has a well-established reputation for research excellence. We're one of Canada's most research-intensive faculties in a wide range of disciplines, ranging from advanced manufacturing, materials, automotive, nuclear, biomedical. In all of these areas, we are looking to transform the way that we do research. You might have thought that university researchers are interested in getting research grants. We absolutely are. You'll find that we spend a lot of money conducting research. Approximately 45 million annually is spent for us to conduct research. We'll write papers. You may be involved in writing papers. You may be an author on a paper. Those are great achievements to disseminate knowledge around the world, and that's very important, but that's not actually what's driving us. What's driving us is to actually see those solutions go into effect. We refer to that as impact engineering. We refer to our end goal is actually to see things all the way through. Some of the things that have been worked on in the recent past, we've developed at McMaster Engineering films that destroy the COVID virus, but also are antibacterial and may well play an important role in hospitals and other situations. Essentially, what is a chewing gum that can store vaccines at room temperature that would otherwise require deep cryogenic freezing. That will allow the transportation of vaccines worldwide to help end this pandemic. We've helped develop the most advanced electric motors for cars, and a spin-out company is coming out of McMaster at this moment to be able to deliver those engine designs to major automotive manufacturers. We've developed an approach to manage energy in a way that reduces the carbon footprint of delivering heat and electricity to homes and residential areas by over 60%. We've developed solutions that have been implemented in Indigenous communities throughout the countries to provide clean water. We've developed new approaches to diagnose and to identify concussions in professionals and amateur athletes. These are all important advances, but the piece I want to tell you is these are all examples of cases where undergraduates have been involved in that research. Undergraduates have participated with those research groups, and in some cases they've been co-authors on the papers. In other cases, they've been co-inventors on patents. So when the dean tells you that this is a tremendous opportunity, he is absolutely correct. And so whatever the job is that you're left doing in the early days of your summer research project, make sure you talk to the other participants, the graduate students, the faculty member, any technical staff and postdocs, about what it is you're trying to achieve, and to understand how you're going to fit into that, because it's a terrific journey that you're participating in. And again, we believe that's valuable to you regardless of your career path going forward, that if you go into industry, you're going to have to understand how new technologies can come out of research labs and how you can implement those and move them forward. If you go into government, again, you're going to have to understand how the nuts and bolts of innovation actually work. It's a tremendous opportunity for you. And of course, some of you will go on to be researchers. You'll get a chance to explore those career options through activities that will be going on during the summer, that will be collaborating with both the undergraduate and graduate students to bring you an interesting and dynamic activities for the remainder of the summer. So I'd like to thank both MacSER and EGS for assisting us or for allowing us to participate in delivering that programming to be more accurately. And I, again, would just hope that you would take full advantage of the opportunities available to you this summer. Come to the annual poster showcase that will happen in August. And I will be around at the end to answer any questions that you might have about the program.
All right, so thank you, Dr. Preston and Dean Ishwar Puri for their opening remarks. I will now introduce the MacSER team. Our team consists of undergraduate engineering students, and as a brief introduction, I'll let all the team members introduce themselves.
Hello, everyone. My name is Yasmin Albana. I'm currently in my third year of electrical and biomedical engineering. As I mentioned in the beginning, I will be the vice president of MacSER for this upcoming school year. My previous research positions include working in the Department of Engineering Physics, as well as the Mechanical Engineering Department, and helping in collaborating with a Forge startup. I'm looking forward to sharing my experience with everyone here and to help you guys reach your goals as researchers this summer.
Hi, everyone. My name's Lloyd. It's really nice to meet you all. I am the VP of events for MacSER, and I'll be planning and attending many of the events this summer, so that's really exciting. I just completed my second year of the HESI stream of the iBiomed program, and this summer I'm working with endocrinologist Dr. Mark Palmert at Sick Kids in Toronto, and we're working on some animal research trials looking at the effects of diet on the neuroanatomy of mice.
Hi, I'm Sarah, and I'm going into my second year of the iBiomed program in the chemical engineering stream. This year, I'll be the VP of communications, and this summer, I'll be completing research in the chemical engineering department working in bioprocessing.
Hi, I'm Jane, and this year I'll be the VP of finance for MacSER. I'm going into my second year of engineering / my first year of hopefully software engineering in the fall. I'm looking forward to starting my research on a machine learning project next week, and I'm excited to hear about all the unique research taking place in Mac this year.
Hi, I'm Salma, and I'm going into my third year of chemical and bioengineering, and I'm one of your VP designs for this year. I'm looking forward to all the upcoming events and research this year.
Thank you, everyone, for your brief introductions. I just want to say that in collaboration with the Faculty of Engineering and the Engineering Co-op and Career Services, our society, the McMaster Society for Engineering Research, is here to provide undergraduate researchers with the community to share their experience within research and to help you guys take advantage of the resources that we have here available at McMaster. We have multiple events planned throughout the summer, accessible both through Teams and Zoom, aimed to help you become skilled in delivering your work effectively, whether that is through writing, whether you're going to do presentations, or through research posters. We got you covered. Next, we will hear from Nagar, who has been a research assistant for 2 summers, followed by our VP events, Lloyd, who will give you a brief introduction to some of our summer plans this year.
Hey everyone, I'm Nagar and I'm going to my third year of biomedical and materials engineering. Last summer, I worked as a research assistant under the supervision of Dr. Sask, and my focus area was in molecular simulation modeling studies for adsorption studies. Even though I didn't have a chance to work in a lab, I still had a fantastic time and learned a lot. This year, I'm also working on another project with Dr. Sask about blood protein adsorption interactions, but from an experimental approach. I was lucky enough to receive the NCER continuous array of art for my research this year, and MacSER helped a lot in the process. I attended the information sessions and learned a lot about the resources and scholarships available. So I would definitely encourage you to participate in the events to not only network with profs and other research students, but to also learn more about the opportunities available. Thank you, and I wish everyone a great summer.
Hi, everyone. My name's Lloyd, and I'm the VP of Events. We just met a few minutes ago. Hopefully you can see my screen, right? Okay, so I'll be talking a little bit about the summer events that we've planned. So we planned some events to create some like a comprehensive summer program for those of you in the Faculty of Engineering Research. All of our events will be virtual, unfortunately, due to COVID, but that doesn't prevent us from having a great summer. So for those of you that were with us last year, a lot of these events will feel very familiar, but we do promise we have like some new and exciting things up our sleeve as well. So for example, our poster showcase is a summer staple that we do every single year. And this is just a great event that happens in August where you get to see all the different kind of disciplines within engineering coming together and presenting their research to one another. We're also planning some synchronous seminars on research, and this year they will be uploaded to our YouTube channel, which is new, by the way, so for everyone to enjoy asynchronously as well. And finally, we're having a whole bunch of social events, and we really encourage you to come to those because they're only fun when we have a high turnout and when everyone's ready to meet other people. So definitely come to those to meet your fellow researchers. The social events are happening on Wednesday evenings every month, and I promise you they're lots of fun. Make sure to follow our Instagram page at MacSER, which will be linked at the end of this presentation, because we will be hosting some exciting Instagram takeovers from a bunch of professionals in various stages of their research careers, so you guys get a sense of what it's like to be a researcher. And then this year, which is new, we'll be doing some contests and giveaways on Instagram. So definitely follow us because that's exciting and you can win some great prizes. So next, our first event of this summer is going to be Research 101. It's going to be happening on May 19th from 12 to 1 p.m. And we're going to have librarian Katie Harding give a great presentation, interactive presentation on basic research things such as how to use a citation machine, how to read papers. So this event, I would definitely recommend it if you are a beginner researcher or a more advanced researcher looking to touch up on some of your skills. In June, we're going to have some great seminars on research collaborations around the world with McMaster researchers, a research alumni panel, a grad studies presentation for all those of you that are thinking ahead about engineering grad school. In July, we'll have seminars on pitch presentations, turning research into an entrepreneurial startup. And finally, we are closing off our program in August with our exciting poster showcase. So how do you, access all of these fun and exciting events? Well, last year we had a Discord, and this year we are transitioning to Microsoft Teams. So on our Teams channel, we're going to host a few of these events, including all of our social events, as well as we're going to be keeping you in the loop about, what kind of events are going on and what kind of resources are available to all of you researchers. So for everyone here who's a researcher, or interested in engineering research, which is everyone here, please copy down the code, which is in the slide right here. I'll also put the code in the chat, but copy down the code to join our Microsoft Teams channel in order to be a part of our 2021 research community. Finally, one last thing. Our social media, which is regularly maintained, will give you a good idea of all of the events that are coming up. We have Facebook and Instagram, and please message us on Facebook or email us if you have any questions specifically for us. But just follow us on all these social media in order to get a good understanding of what's going on this summer. Thank you so much for listening to this presentation on events.
All right, thank you, Lloyd. So we would now like to pass it back to Dr. John Preston, and the floor is open for any questions. please submit any questions using the link provided in the chat. Someone did mention that it's asking for a code, so I will go ahead and send that code in the chat as well. If it's asking for that, that should be sent. And I can start off with the first question. So our first question is, what are the possible pathways that research can lead to aside from a master's degree?
Oh, okay. So, so a master's degree, or alternatively, you can continue to go and get a doctorate. Both of those degrees are terrific options, but they're not the only option by any means. So most of the students who've been conducting research in my group have gone on to industry positions. When they go into industry, they're often sought out as people who have developed practical skills and also have and can talk about solving, as Dean Puri mentioned, the small problems that make up the bigger challenge of discovering something new, but also creating something new. And so that's actually what companies do as well. It's not just university researchers. When you look at anything that you've seen produced by a company, whether it's been manufactured, built, or organized, they will have gone through a process of breaking down what needed to be achieved into smaller pieces. And then they will have many, many different people who come up with creative solutions for those challenges, but also making sure that they all integrate together into a well-defined whole. So it really does translate to a number of career paths very well. It gives you the kind of stories that you can tell about your talent set. It also gives you an opportunity to develop a relationship with people who are a little bit more senior, who can then provide reference letters and make contacts for you.
All right, thank you. The next question is, what activities are planned to make online summer research more interactive?
Okay, great question. So those will depend a little bit upon the research group that you're working with and how they actually interact. I guess many of us become normalized to the idea that meeting through Zoom or a Teams call is almost equivalent to the real world, but of course it isn't. And so I think there's a give and take that's there. You should really look to use the tools that are available to you so that you can have the equivalent, or as close to the equivalent, of an in-person experience that you might have. And I'll actually give an example of this. I work very closely with Sarah Nova-Zedlik, who's actually listening in on this, who's the research facilitator for the faculty. During the course of the day, we may meet, in much as we're talking here, 2 or 3 times. But generally speaking, in the real world, we would be in adjacent offices, and occasionally we would just stick our head around the corner and ask a question. So I see in chat regularly, there'll be something will pop up just for a quick question. Quite often I can be engaged in something else and I can give a response back to that. And for us, it allows the flow of our workday to look a little bit more like it would in real life. The one thing I think is really important, though, for all of us, is that if you're somebody who tends to be a little bit introverted, try to make sure that you make that effort, particularly at the beginning of the summer, to actually reach out and have conversations with some of the people that you're working with. I don't think you'll find that if you reach out to a graduate student or to someone else and say, there was something, I just want to talk to you a little bit about A, B, or C, and it may not be even work related. You won't find that to be particularly difficult. It's a lot easier to do in the real world. It happens all the time. Here we have to kind of work a little bit harder to make it happen. So please try to do that. And I can tell you that I'm talking at the other end to your supervisors and the research groups and telling them essentially the same thing. Make sure that you're reaching out, that you're initiating conversations, because that really will make it a much better experience.
Awesome, thank you. So we're getting a few messages in the chat that are from future students. So first of all, thank you so much for attending. And there's a question if you're supposed to be here. Yes, this event is for everyone. If you're thinking of coming to McMaster, we're more than happy to have you at our events. If you are trying to join the teams, then you might have a couple of problems just because you have to join with a McMaster email. So I just wanted to give you a heads up that instead of joining the teams, please feel free to follow our social media and we might be able to open it up. We have to double check the team settings, but just for now, follow our social media and we can post updates about that teams channel there. And then with that being said, the next question would be, how do you apply for research? And just how do you apply for research?
Okay, so this is coming from a future student. Applying for research is pretty straightforward, but you do have to put in some work. And so part of it is, one of the things of being a university professor is that your professional life, at least, is quite public. So all of us will have websites. We'll describe what our research activities are, what our aspirations, why we think it might be important. And so if you look in our websites, and you can do this either by departments or by research areas, and you'll be able to find through different ways you might find, because I think in just as people were introducing themselves, students don't always end up doing research in the department that they're studying in. So find out people who are interested, find out more than one. Reach out to them, ask to find out a little bit more about what they're doing during the summer. Also attend events that are organized around that. And what you'll find is that if you reach out, all of us would love to have more summer students participating in our research. Generally, the limitation is the amount of support funding that we have available. But if you reach out and you show interest, we're all human. So when somebody comes and they say they find the research that I do fascinating, I'm always delighted about it. So I'm then looking for a way to bring that person into my research group. And so make sure that you try a few different groups and just open up that connection. There'll be there's financial support available, both through the faculty, through some departments, and also through NSERC to support students to work within research groups. Those deadlines will be known, they'll be referred to you through your department and for first year students through the level 1 information channels.
Thank you for your answer. Our next question is asking, what advice do you have for a first year working in an area of research that is quite out of the scope of first year curriculum? How can we make the most out of it?
Okay. So the first thing, the dean talked about being a scholar, right? And I often talk about being a researcher because there's a subtle difference there that's actually not so subtle. Scholars typically refer to people who have deep, profound knowledge about a given area. Like if they're a scholar on Shakespeare, you can ask them anything. Researchers like myself, we spend our entire careers trying to learn new things that we didn't know before, which if you think about it, means that I spend all of my time working on things that I don't know anything about. I'm not really qualified to do any of the things that I do, neither are my students. So don't be intimidated by the fact that you don't have the specific knowledge. We're trying to gain new knowledge, so that's okay. The other thing is that we've talked about breaking down work into small groups, into small compact disciplines, right? If you're working in a chemical engineering lab, then what you might find is that having really clean glassware is crucial to getting the results that you want. I remember myself being trained in how to wash glasses properly, and now I do dishes better than I ever would have otherwise. But all kinds of important skills are there, from coding to assembling things, to running tests and diagnostics. It's really all about being mentorable, about being willing to listen to instructions, about taking care in the things that you're working on, and about being very forthright about when things don't go the way that you expect, that you make sure that you talk to the right people within the group, either the graduate student that you may be working with or your PI, depending on the nature of what you're doing. So I actually a former graduate student of mine reached out to me on social media. It was actually a bit of a poke. It was about what he was answering a question that somebody else had posed. What's something that your former supervisor said that keeps running through your head? And the one that he pulled from me is that give me an army of summer students and I can do anything. And so I actually believe that. I think that there's tremendous power in cohorts of students working together collaboratively. And I've had undergraduate students that really have done absolutely amazing things.
Thank you. Our next question is, how reasonable is it to consider completing 3 summer co-op research terms on campus to obtain the co-op degree designation?
I mean, doing the entire co-op designation and research lab, that happens all the time. So it's and there's multiple ways to do it. So some students go into their first research exercise or activity with one researcher. They make themselves invaluable. They get invited back for the subsequent summer and summer after that. And so they've gone on, and in doing that, you have the advantage of gaining deeper and deeper experience within that research group. Other students hop between 3 different groups, and they actually bring a remarkable value as well, because what they do is they can provide a bit of a glue in terms of sharing best practice. We often find that it is the junior researchers who tell us, oh, I did this a little bit different in Professor Didar's lab than you're doing it, and we were able to do it twice as fast or better or something like that. And so of course then we would change the way that we might do some activity.
Awesome. And our next question is, what advice can you offer for someone starting a research position and dealing with major imposter syndrome and generally feeling anxious about the position itself?
All I can tell you is that I've dealt with imposter syndrome my entire career. And I've been around McMaster for a long, long time. So it's a challenge, because remember what I said at the beginning, right? We're trying to do really great things. We're trying to, provide clean water to communities. We're trying to address climate change. We're trying to address the pandemic. We all get caught up in these things, and it's like, why would we be doing that, right? Shouldn't that be some more famous university, like Stanford or Oxford that is doing that? The reality is that McMaster is a global top research university. These other places recognize us as that. But we are probably the most Canadian university on the planet, right? I mean, but part of that is a strength too. So if you have imposter syndrome, don't think of what you're doing, think of what you're doing with your team, because many people who are shy about taking credit for what they can do can get behind working with an exemplary team. So get to know the students, the faculty member that you're working with, get to bond with them as a team, and then just believe in the team. And that's okay, because you don't have to be the Matthews Austin Matthews on the team. You can be the great defenseman that allows Austin to be free to score goals, right? So think of yourself as a team, and that the contribution that you're making is going to be solid in the team. Believe in the team, and then go out and take a shot. Understanding you probably, I'll be a little bit honest, we aim high. We mostly don't hit the targets we're aiming for, but if you aim high enough, what you achieve is still pretty good, and every once in a while you're able to do something remarkable.
Thank you for the answer. Our next question is, do you have to maintain a specific average to do research?
You don't have to mean they're not tied together that tightly, but they are tied together because research performance within your coursework is one component that goes into determining financial support. So McMaster Engineering tries not to make things hyper competitive. That's not what we're about. We're about working collaboratively to achieve great things. But we do have to make decisions. We do have to make decisions about who gets scholarships, about where our financial support goes, about who we're able to bring into our research groups. So that's one component that goes into it. And so absolutely you should never allow your work in a research group, or alternatively your work in a club and team, which is equally important, to take away from your academics. You want these things to augment and support each other. But generally speaking, it's probably not the biggest challenge you're going to face to maintain your grade point average to where you're going to be able to conduct research. And what I can tell you is that research taps into other attributes that aren't typically tested as well, at least in a conventional course, because it requires other attributes that, in terms of creativity and imagination, that is hard to bring into a course. And that's one of the reasons we value it so highly.
Awesome. So our next question is, how do McMaster researchers set themselves apart from other schools?
Okay. So I mentioned this idea of impact research, right? Trying to see things through to the final end. That's going further than where the academic glory is. So it requires that commitment that you really buy into. It's easier to just get to the point where you write the paper and go on to the next paper, and that's the way that most academic institutions tend to focus and what they tend to reward. So we're trying to move to rewarding where we give back to society, so we put that extra work in. The other piece, though, that's really important is that writing those papers, in many respects, it's more effective to do two things: to stay in your lane, stay within your discipline, stay with the things that you really know, and to work by yourself, because sometimes collaborations can take a little bit more time to align yourself with other people. But those two things restrict you from being able to do really amazing things. Almost everything that's really important is multidisciplinary, and most of it involves things outside of engineering aligned with things inside of engineering. So we actually put money into supporting people to form multidisciplinary teams, and we've had tremendous success in terms of doing that. And we support collaborative activities in everything that we do. So those two things, to try to be multidisciplinary, you want to have a discipline, you want to have deep discipline knowledge. That's what you're getting from your main program, but you also want to understand all of the different applications that could be applied to, and then develop other domain knowledge. So think collaborative, think multidisciplinary. Those are the things that set us apart.
Perfect, thank you. Our next question, I'm going to kind of combine two in one because they seem to be around the same point. How well are research positions viewed by the industry, and do research positions help get you an industry position?
Absolutely. So when we talked, Dean Puri talked about the origin, I guess, of the expansion of the undergraduate research program and us investing our funds into it. That was in part done to make students, to give a better experience for students. It was in part done because we have an industrial advisory board, and they told us it would be a great thing to do. It was part done because parents really loved it. They loved the idea that their son or daughter would be able to gain experience earlier in their academic career, right? And so what that allowed us to do was to get more people at a younger stage, after level 1, after level 2, involved in research, whereas previously it had been mostly, to be honest, level 3 and level 4 who've been participating in the research program. Now we have everybody there. What does it do for industry? Well, you have to be able to talk to them about, because not all industry will understand university-based research. You've got to talk about the contributions that you were able to make, the things that you were able to learn, right? Which are these small things, maybe small things seeming in of themselves, but that you became quite skilled in, right? That you learned how to use a soldering iron appropriately so that the circuits you created would be robust and would last a longer time. You learned how to do layout, you learned how to do some machining construction, you learned how to do a certain type of modeling, you learned about operating AI programs or other types of software. Any of those things start to go together. You're basically plugging in pieces in your CV that the industrial people will recognize. And then also think about the accomplishments that you are going to achieve. By the end of the summer, you'll have achieved certain things. People in companies are always looking for you to tell a story about how you took an opportunity, like a summer research experience, you learned new skills, and that you achieved some things coming out of it. So I think if you can articulate those things to companies, you'll find that they're very receptive to do it.
Awesome, thank you. So I will also combine 2 questions. So the question is there research positions available for the fall 2020 term? And where would you find relevant information and how to apply to them? And then also combined with this, is it possible to get a research position or award in the late summer?
Okay, let me answer the first one. I'll go with the first one first. Typically, so the answer is yes and no. So the yes answer is that if you're available to do a co-op in the fall, that there may be positions that are available. It's not where, because of the way that our school year is structured, it's less common, but there are definitely students who are working in research groups during those times. And sometimes we even have some support that we're able to put into it, although most of our support does go into the summer program. The no part is it's not possible to carry a full load of courses and do a research term at the same time. These are 2 full-time jobs, right? And I'm not going to, for the minute, tell you that your time is not going to be busy when you're engaged with your courses. For the students who are coming in, people here would be able to tell you that. And certainly when we have students working in our research groups, those are full-time positions. But there are groups that are open to having students who volunteer with those groups for 5 or perhaps 10 hours a week. And that's a mechanism to develop those skill sets that I talked about otherwise while you're in the midst of doing your courses. So there is opportunities, and I will tell you that second situation, trying to get more students to have, if not a full term of research experience, to at least get a taste of some research experience, is one of the next challenges that the dean has given to me, is that we're going to be looking at mechanisms to try to put more students into more research labs and have them be able to make a contribution and gain valuable experience.
Thank you very much. Our next question is, how popular is grad school for McMaster Engineering graduates, combined with basically how often does research experience help with graduate school applications? Oh,
every single time. Every single time. So I mentioned that research overlaps with what you're learning in your courses. And actually, we're increasing that overlap with the changes in the curriculum. But they're not really quite the same thing. So research is often about unstructured problems. And I'll give you one of the reasons. I mentioned, about what a researcher does. They're trying to do things that have not been done before. We're trying to discover things we didn't know before. We're trying to put things together and create a solution that's never been done before. Often that means we don't know that we can do it. We may inadvertently give a problem like that as an assignment in a course, but not usually. So usually we're in a course, you're trying to, you're going back over previous track records. So they're different, and those same skills that I said would work for an employer. With my graduate group, it's all university money, but it's university money that I brought to the university by my grant applications, and I have control over it. So I'm a little bit like an independent company. And so when I'm looking at graduate school applications, I'm a little bit like an HR department, right? I'm looking there and I'm trying to say, okay, I need somebody who's going to be really good at programming on this project. And here I get an application, and the person not only has the courses, but also has experience working on it and has achieved something with it. Then I'm like, okay, wow, that's great. I'll bring that person in. Or maybe I need a different kind of skill set. So you're always looking to try to, we're always in competition, not with each other, but with everyone else in the world to try to solve these big problems. We're trying to create the best team that we can and the best fit amongst the team. And so that's the other piece that I would tell you is, that's why I said to look at applying to more than one group, because it's not about how good you are. Don't take a rejection as being you're not as good as the other person. You might just not have been the right fit. So you're always looking to get that fit, and you have to, in all things in life, you want to find a perfect fit. You have to look and explore different options.
Awesome, thank you. And then our next question is it possible to get a summer research position in an international university, such as one in the USA or Europe?
Well, yes, it is. And we've had students do that. And sometimes we try to help them to overcome obstacles that may be there. But what you should understand, although many of us feel this imposter syndrome, I have many colleagues at Stanford. They think McMaster students are the best in the world. That's full on stop. They see the students as being mature. They see them as being team players. They see them as being extremely knowledgeable, and they see them as being highly motivated. And so the leading universities in the world want access to you. The leading companies in the world, Tesla wants you, right? So you should have a bit of swagger. Walking around in that typical imposter way. So it's a strange way to go about your day, but you should have that. And so absolutely you can do it. And the mechanism is more or less the same. You're going to look and find out what different research groups are doing. You're going to reach out to them, and you're going to tell them about why your interests are there, and what skills that you bring, and why you might want to do it. And because those, and I'll be clear about what their motivation is. If a group at Stanford hires you as a summer student, they're not interested in giving you a great Californian experience. They're interested, they look at you, their HR mindset looks at you and says, this would be a great grad student to bring into this group. And if I bring them here for a summer, I'm going to have a terrific opportunity to recruit them here, which is really my end goal, that I want to see, I want to add a permanent member or a longer term member who's really got these, this excellent McMaster DNA attached to them. And that's how that will go. You probably have to look even a little bit, you do have to look wider, because different research groups around the world have very different ways that they operate. Some groups are massive, and the way that summer students would be brought in is not through the faculty member, but through postdocs and research engineers and things like that. So some groups work with summer students on research, But you've heard McMaster does that more than anybody. On a per capita basis, the most in North America. So, but there's lots of other schools who have the same kind of mindset, and there's lots of other terrific researchers. And we're not looking to hold you back from that, because what we think is that when we have students who work in our research labs, students who work at world-leading companies, students who work at important Canadian companies, students who work at other university labs around the world, and we bring you all back together, that then we have a much richer and more interesting environment that you get to learn not just about what's happening in the research labs at McMaster, but also at companies and in other universities that you didn't personally have experience with, but you know students who did that. And so you get to pick that up by osmosis.
Awesome, thank you. So I just want to be conscious of time. So with 6 p.m. approaching, that concludes our formal question period. Thank you to everyone who sent in a question, and thank you to Dr. John Preston for your insight. A huge shout out to the MacSER exec team for making this event possible, and to the Faculty of Engineering staff for helping with this event. So to any incoming, current, or even future students, thank you so much for attending our research kickoff, and we hope to see you at our future events, starting with Research 101, which is happening next week. So if you're looking for more details on this, keep an eye out on our social media for more information, and we will be sending out an email within the next couple of days with more information about our teams and how to stay informed.